So we're gonna talk about hash table. What's DR?
Okay.
If you are in, hello. Did someone say that? So if you are in Alex, you probably did hash tables. There was a project about them. It was fun. In C. This is documents that have kind of like summarized. I posted also in Discord. And let's understand let's understand the hash table. We're gonna watch a short video, so when we jump to let's code, if someone like didn't understand hash table, he can like follow up with us, or we can also Shaza, you wanna like give us a quick scope on hash tables? You can share screen if you want.
Yes, okay. Yeah, okay. Let's start something about hash tables and what are these.
Okay.
I will share my screen.
Okay.
Okay. Okay. And second, let's bring it here. Okay. Okay. Let's share for in the beginning. Okay. Get this also. We will need this here. Okay. We need to understand for first what are hash tables and why do we need them. Maybe we like to store our data in something simple like arrays or linked lists. So what is the need to hash tables? Suppose you have a very big store, like a store of tools, like you have very different types of tools, like you have nails, hammers, or whatever. And this big store, you need to get very fast access to what you need. I need nails, so simply you can say, hey, I need nails. So you are directed with certain index, unique index, to know which shelf and which room you are keeping these nails. So the need is very fast access and a very organized structure to get what you need, especially when you have something like very variety of tools or very big tools. This will be very beneficial. So if I'm going to pick arrays, you will say, oh, I need to maybe I loop array indices one by one to share to search for my nails, and this will be a time complexity of O of n. You are visiting each element, so arrays won't be the very good way to access what you need or to search what you need. Maybe you would like to say, okay, I will use something like linked lists, but as we might know that linked lists are scattered rooms in the memory. You don't know, you don't have the indexing of the arrays. You have to visit each node because the address of each node is kept in the previous node to know how to traverse the linked list. You can traverse it forward. So this is also, in terms of time complexity, it isn't the fast option. So how hash tables can solve this problem? Okay, simply I will share here. For example, I said, okay, I have nails and this is key. My key would be like these strings, and I will have also value. So if my data is needed to be kept as key or key and value, so hash tables also will be something beneficial to choose them over other sorts of data structures. But how we are going to do this? Let's consider that we have index, okay, maybe this smaller. Is my voice clear?
Yeah, it's very clear.
Okay. Okay. So I need to stay here index, and here we have like slot that kept my data. So for simplicity, I will say 1 nails, or let's say not nails. I will keep say the value. I have 800 nails. This is so. I need it smaller. Okay. For example, maybe I have index 2, which refers to hammers, for example. And I have in my store like 1000. But we need that the index isn't that just like 1, 2, 3, 4, 5. You need it to be very unique, okay, very unique, because you will access the hash table through this index. I will say, hey, get me what in shelf 3, 4, 5, 6. So you will give the data stored in the slot. Let me remove all this. Okay. So let's say we have the string like nails, which will be stored. So I can make use of something called hash function. This is like a mixer where our hash function can make us a very important favor, that it will convert nails into a number. But how is that? This is so easy, like you are getting the ASCII value. We will make use of ASCII value. It will help me to make the key of the nails very unique, like in ASCII value plus A plus I plus L plus S ASCII values. And I will maybe make it more hard, or make formula more robust, like you will find it like modulus something like the size or number of the count of the string numbers, like 1, 2, 3, 4, 5, like this. So this will give me a number, right? Is that clear, or I'm going so fast?
It's clear. If someone have
Okay.
question,
Clear, clear,
feel
clear.
free to open mic
It's
or
clear.
write in chat.
I resume or something? It's okay, or
Yeah,
any
Yeah,
questions? I
it's
don't know. I
okay,
can
it's
see the
okay, it's
chat.
yeah,
okay.
Okay, okay.
it's clear.
So by the help of the hash function, I could convert my string into a simple number. This number will be taken to be my index, like I have something like 3611. This is denoting what? This number refers to what? If you could understand me, this numbers, I'm sorry for the very fat line I'm using. I can't make it, I don't know how to make it smaller. This number denotes what? If I hash function give me 31164, this function in index, which I got from the nails. So it will be the key that denotes nails. So my cupboard now, or my hash table now, will have it as the key that denotes nails, and the value will be the count. For example, I have 800 nails. It will be like 31164 index, and the slot contains the value or the count of the nails, like 800. So I got a very unique number here as an index, okay? And it can be, if I have another tools like hammers or whatever, by the help of ASCII number and the help of a hash function, I will return it as a number in the index and a slot. This slot contains the value. So the number here, or the index, is the key. And here is the my data, like frequency or count that I want to keep as directed to or related to the nails. Till now, is it good for now?
Yeah,
Yes, it's clear.
Okay, so if I need nails, I will go to the number which is denoting nails, which is unique. So in terms of time complexity, this is O of what? If you can
I think
relate.
of one.
Yes, great. I didn't loop anything. I didn't fetch or try to fetch any other key. I just have the index, so I went to to the correct shelf from the first time. I directly went to this. So the hash tables is very, very time efficient. When you are considering time efficiency, it's a good choice to go to the hash tables. One other thing too that we may hear about it, which is, and we have to take care of it, is what we say, collisions. What if I have strings, okay, two strings, but they have same ASCII value? Let's say like John and what any or maybe like I don't know any an example that two strings in my mind now, two strings that have ASCII value, but it can occur. Okay, so when it comes to the hash function, that depends on the sum of each ASCII code for each letter. So and even if I make modulus any number, like the count of their number, like here ASCII modulus 4, so I got the same index. Maybe both give me a number like 3, 1.
You can just reverse the word, reverse it.
Just reverse it.
Yeah, reverse it, and it will give you the same. Yeah, because it's the same word, or just. Yeah.
What about silent and then listen?
Yes, exactly. This is a very good example. Listen and silent. They both have the same sum of ASCII values of letters. Excellent. Yes, this is a problem. That means that listen will come to the slot here at index 31, for example, and for simplicity, then I want to get silent. Silent will maybe it kick listen from here and will be here, maybe kick it from the memory. This is a problem, and maybe cause us something like unpredictable behavior in my data. May cause a loss of some data. So how we can take care of collisions? Actually, there are two ways. Before going forward, did we understand the problem itself of collisions, how it may come, and what's the bad in causing collisions? Is it clear?
Yes, it is.
Can you explain what is collision?
I don't know. I'm joking. If we have an input and
Yeah.
we save it to our, for example, in our hash table, and we
Yes.
got, so when we pass it through the hash function, it give us like a ID
Yes.
or like a index
Yes.
where we're gonna place it. So
Exactly.
we might get some input that's gonna give us the same index. So we're gonna have like we need to save it in same place. So
Yes,
that is
exactly.
collision.
Yes, and this is a problem because it may cause loss of data or unpredictable behavior. So I have to handle collisions. How can we handle collisions? Let's say that we have two ways for collisions. We said that we have like a slot like this index, an index, and the slot here to keep data related to the index. Okay, we may do something like chaining. What is chaining? I will say, okay, when I came to 31, I will make my data like silent here. Then I came to listen. I will check, is the slot related to the index not empty, it has silent? I will say, okay, I will make it like a linked list, and silent will be just a node. After it, there will be another node which keep the another word or the another data with the same index, like listen. Listen will be here. So I have the same index, but in the slot, I have all values or all data in a linked list that is related to the same index. Is that clear?
Yeah.
This is called chaining.
Chaining, yeah.
Yeah, this is a way to do that. Another way to handle collisions is to make it very, very hard that the hash function give me the same index.
Yeah.
And how is that? The more you make the formula or the hash function formula hard and complex, it is hard to repeat the index.
But I
Like,
think I think I
yeah,
think
yeah.
I think it will makes it hard because we need to resize the hash table every time. Like if we have um 20, 20, 20 element in this hash table
Yeah.
and size is 20. Okay. When we add another element to this hash table, we will need another another placeholder or another place for this element, for the new element. So we need, each time we add a new element, we need to check if it is,
Yeah.
if the hash table is empty or not.
Yes, this is
So
correct.
resize it again.
Okay, it is hash table is something in nature as a data structure. It doesn't have to have a size. It is you are free. Yeah. Let make example in Python. It will be called like dictionary.
Okay. Yeah.
Okay, so
Yeah.
the dictionary of key value, you don't have to decide
Okay.
what
Yeah.
size
Yeah.
of it.
Yeah.
Also in JavaScript, I think it will be
Yeah.
called
Yeah.
object key
Yeah.
value, right?
Yeah. 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 It will be, yeah, it will be
Like
easy.
that.
Yeah, it
Yeah.
will be easy. But I think it's I think in low level programming, it's kind of hard to implement this.
Yes, it would be horrible because
Yeah, yeah.
low-level
But
programming is horrible in
but
everything.
yeah, but the answer is to resize the hash table every time you reach the highest. Yeah, yeah.
This can be clearer if we can investigate how to make a hash map in C, and to investigate the procedure if we are handling collisions in making linked lists. I think this will address this issue very clear.
Yeah, yeah.
You can
That
make
is
it, yeah. Okay, you can make it some search together today.
yeah. Inshallah.
Yeah. Also, like one more thing, in lower level programming, you often have to define what, like in C, which is more low level, you have to like define. You are building your own hash map by yourself. So you mainly decide how you're going to do stuff. But unlike maybe more higher level programming like language like Python, there's already a system, like we have an implementation of a hash map like dictionaries and stuff like that. So I think it's just based on you decide based on how you're going to implement maybe your hash function in C or some other lower level stuff. So I think the decision comes to you most of the times.
Yeah. Here in this Jeff, I think it addresses dealing with this. If this is in the index 0, 1, 2, 3 for simplicity, then in this slot, as you see, it has something like lizard, key and value. The next pointer that will point to a second node, which has the same, let's say, same index, like 3, when it comes here. So the next is none up till now. Then it will denote here none, sorry, now next is referring to cardinal, which is another node, and so on. This is a way which is maybe complex in terms of creating a linked list for each index and checking if it is empty or not, as you have said before. But maybe it's a way to handle collisions. Maybe it isn't the best, but it's a way to solve the problem. Is it okay now for
Yeah,
this
yeah, yeah,
procedure?
yeah.
Okay. Let's consider the other way to handle collisions. We said that if we succeeded to make it very complex hash function, so it might end up to make it very complex. Like I think, for example, you get the ASCII value and multiplying it in a prime number, any prime number for your choice. As far as I remember, we can revise it and make it modulus the size, or maybe size to the power. I can't remember. Monsef, can you share GPT hash function formula to handle collisions with us and share it with
Okay.
us?
Okay, one second.
I will stop sharing. Okay.
Also, I just want to say something like
Yeah.
saying we are going to create a hash function that handles collision. I don't think that is very feasible. I've not really read much on that aspect, but somehow, even if you write a hash function that makes it very difficult for collisions to occur, it only makes it very difficult. But there's no certainty. There's no certainty that a collision cannot occur. So collision. So I think yeah. So collisions can still occur, but just that it's very difficult. So even
This is
if you want
exactly correct. And I have read this before, that even if you make it complex, you may lower the probability of collisions, but you still can have some collisions. You are completely correct.
so you still need to handle collisions. Even if you use this, you still have to
Yes.
maybe
Yes.
handle collisions, and while hoping that they don't occur. So that's just the point.
But
Yes, exactly true.
increasing decreasing the probabilities. Yeah.
Okay.
Make
Monsef,
it
I will stop sharing to share with us the hash function.
Okay. Do I write it in chat? So like this.
We can ask ChatGPT about hash function and the formula, how to make it guard against collisions, something that way.
Okay, give me a second.
Okay.
maybe binary. Binary will fix it. Everything fixed by binary. What do you think?
Binary as. Let me share screen.
Okay.
Hash function. Okay, that was. Can you see my screen?
Yes.
Okay, what do I ask? Let me zoom out.
Like a hash function to handle collisions or to make collisions less properly, something like that.
How? So I am using hash table, and I want a low chance for collision. What do you recommend for my hash function?
Great.
Should be Python. Keep it simple, please. Seriously? Okay, so he's using, I think, built-in function, or okay.
Everything in Python is very simple. What
Okay.
about English in Python? Yeah.
Okay, so
The
he's
thing is that Python has a lot of inbuilt stuff. So the best place to really look at things and appreciate it will be C. Like
C.
Python already has implementation of
Give us
like for learning, you're using
C
Python.
in JavaScript. You're right, yeah. Okay.
JavaScript doesn't have a built-in hash function, I think.
So he's building it. He's building a function.
JavaScript has maps and objects. They're kind of like
Yeah.
they're kind of hashing.
So we can see this one. So this hash function, he assign variable 538 random
Long, okay. Oh.
So this is like a code that you're gonna create with its formula, I believe. and then he did use bit
I
range.
think this is an arbitrary number. You are free to set it like as you want.
Yeah.
Okay.
So every time I give it a string, it's gonna give me like a unique hash. Okay, we can try this code. See online compiler. Okay, this is doesn't look okay. Oof, my eyes. Okay, so how we can test this? So we have a key, example key, and we give it to the hash function, and it give us the value. Okay, run. So the value is this. If I run it again, it should give me the same number. Okay, let's pass the number here. Run. Okay, it is the same. So this is
But
one of important part. It should give us always the same.
yeah, but just like this particular hash function does not take into consideration the size of our array. So
Yeah.
Yeah,
It's still we still have a collision using this. If we have like array of size of 10,
but
so
maybe we can like do model of
it's
size of array to this number.
modulo of it give us the if it is 10, it will give us it will take the last digit.
Like
If it is
model nash.
okay,
So
12
it's gonna put it in index 5 all the time, always,
all the time and always okay. But if you
right?
change it, try to change it.
So this is like the size of array.
Mhm.
We have nash places.
12, yeah, 12 places.
Nash. It's Arabic. Okay, 12. Yeah, so like 12 places.
Okay.
I guess this is
Try,
right, Shaza?
change it, Monsef.
The word.
Yeah,
So
change the word.
key. So now it's 11. So this value is
Okay.
gonna be saved in
No,
the index
okay.
11.
I think it
Oh.
in C programming it depends on the size of the array. It didn't. I think the prime.
So like
Mhm.
this gonna generate a random number from our like this from our key, the first key that we give it the random number. So if
Mhm.
so like what we want is if I give it hello,
Mhm.
it should give me this unique number, right? This unique number.
Okay.
So
It
because
will give
when
you.
someone gonna search for hello, I'm gonna use the same
Hmm.
function to
Mhm.
find out where it is stored. So
Okay.
if I reverse the function, I should it should take me to that data that I save in my array, right?
Hmm.
Okay. Array of size of what?
yeah.
Okay, it's
Yeah.
it not 12.
12. Okay. Run it again.
Okay, 9.
9.
Run
Hmm.
it
Okay.
again, 9. It's gonna
Uh,
save it always 9.
yeah, in 9, but you need like a linked list or something because I don't know.
Y- yeah,
Yeah.
like if I think this is the other
The
part
limit is
of
yeah.
adding to the if so
Limit
if
is
I was
nice. Mhm.
so like let's say example of adding elements to array
Uh,
or like example in C adding element to array uh, and we have collision wanna solve it with link list.
uh,
Keep it simple.
uh.
So at somewhere here we're gonna have the collision. Check if and this is empty. Okay, this one right here. Collision
Okay.
occur. Append the new node to the link list. So
Mhm.
here we did uh, check if the so like he did check if the index is empty, right?
Mm-hmm.
Because if not empty,
Yes.
that means some value already stored there. So
Okay.
I can't remove it, right? So what he gonna create, he's gonna append the
Mm-hmm.
new node to
Mm-hmm.
that existing node. Like Shaza show.
Mm.
Let me see. Hash table link list. Um, link list collision. So it's gonna be something like this. Like this. So he did find 50 here. Area did there is 50.
Mm.
Then he append this link list to this. Uh so who have question or anything about hash table? You can like
I think
try. Yes.
I think my point is like the collision it depends on the array size. Array size. It's not. It doesn't depend on the function hash or something. If you have like array of
Mm,
size 10 or array of size 9, those low numbers, it's kind of hard to like. It's impossible. It's impossible like
yeah, I
uh,
get you.
to
Yeah.
to avoid the collision. Yeah, but if you have, even if you use, even if you use the most,
Mm,
the I don't know how to say it, the greatest function,
mm.
the
You're
greatest
gonna.
hash function,
Yeah.
you're gonna still have a collision because it's so small, and
Yeah.
it's a small array. So the when we need when we really need a hash function is when we will have like an array of size of 1000, 10,000 of that much of a, yeah.
Mm.
But if we still own 15, 100, we don't need that kind of hash functions. Need like,
Um.
yeah, because it's not, we just, I don't know.
So
That's
And
my,
I also want to say something.
yes. Go ahead. Yes. Go ahead, please. Hello.
Manage stuff like that. Normally, if you resize an array, it means that you're going whenever when you resize an array, you actually have to when you are doing another calculation. It means that you are going to actually lose the indexes the previous indexes that you calculate because, of course, you calculate the hash based on the where you are going to put the value based on the size of the array. So you calculate the hash on the size of the array. So if you resize it dynamically, then you have a problem. Like, so you have to have a fixed size because if you change the size, you are definitely going to affect the previous sizes that you calculated, and that is going to be a problem.
That is true.
So,
This is true. There's a part who in the Google Doc I shared. There's parts who would talk about this. So we talk about like two type separate chaining and open addressing. So in separate chaining you can have uh, uh, many value in same index, right? But in open addressing you can't. So each value have specific index. You can't add more. So what you do is you just keep looking for the next empty uh, spot in your array, right? So at some point you're gonna have full array because you're gonna keep adding. So what you do is you need to resize it. So in open addressing, when all slots are full, the hash table is said to be completely filled and no more elements can be inserted into the hash table. However, in practical application, it's not a good idea to let the hash table get completely full. Performance degrades significantly when the hash table is near capacity. This because as the load factor, the ratio of the number of elements to the number of slots increase, the likelihood of collision and the cost of. So this is the point that Omar talk about. Like the more it is like kinda like the area is small, the more you're gonna have collision, and the cost of resolving them also increase. To handle this, a common strategy is to resize the hash table. When it reach a certain load factor, resizing involves the following step: create a new hash table that is larger than the current one, the size might be chosen as the next primer number or simply double the current size. For example, rehash. So this is the point that Inbank talk about, is like you can't resize because if you resize, that means this this function right here, this function right here, it was calculating with 12, so it give you 9. So now you have array of 30. When you're gonna run it, it's not the same position, so you're not gonna find that element. So here rehash all the keys from the current hash table to the new one. This is necessary because the change in the size of table will likely change the hash value of the keys. Replace the old hash table with new one. So I think uh, when if you get
Yeah.
selected the option to resize,
Mm.
you will have to rehash
To
everything.
rehash it, yeah.
If there is no question, we can like jump to
Mhm.
let's code and try to solve it together. Brainstorm, maybe do a pseudocode together and see uh, how we can use like hash table to solve it. What do you think, everyone?
Let's go.
Someone asked, so what is the substitute of hash table in C or alternative? Anyone can answer?
No, well, in C, there's no substitute for hash tables. You have to implement. If you want to use a hash table, you have to implement your own. Of course, you have to.
I didn't understand what is the question asking about. If someone can
Yeah,
explain.
you were saying something like substitute for hash table in C. I didn't even look at it, Christian. But just based on what he asked, like C doesn't have an implementation of a hash table like we have in Python or JavaScript.
Uh,
Like you have to implement yours by yourself. I think we did an exercise on that in
yeah,
PLD. Yeah.
yeah. So what you think we solve some let's code?
Sorry, can I
Yes,
ask the
go ahead,
question,
Pascal.
please?
Go ahead, Pascal.
Talking about resizing,
Yes, please.
I feel that the reason why we are resizing is because we are using an array, right?
Mm-hmm.
What about if we are using a linked list? We don't have to resize.
No, but the time complexity, we need like
I just want
smaller
to know. I
time.
just want to get the point of resizing.
Yeah,
Like if we are using a linked list,
uh-huh.
do we have to resize?
No, we don't. We don't.
Exactly. And I just wanted to clarify something.
Yeah.
Yeah. So
The,
thank you.
the solution of the collision is there is two solutions: the linked list and resizing the hash table.
No,
I am so sorry.
you're not getting my point. I mean,
Uh-huh.
storing of the data itself, not collision. I'm not talking about the collision yet. Like,
Okay.
I mean the storage. I don't.
Yes,
Storage.
Let's say I don't want to use an array. I want to use a linked list. For
Linked
that.
list.
I don't want.
Okay.
I don't want to use an
Okay.
array.
So it's not
So,
a hash table. Okay.
like, no. I mean, I don't understand. So
Okay.
I have to use an array for
Mhm.
hash tables. That's what you're trying to say.
Yeah.
Okay, it's fine. It's fine. All right, thank you.
Thank you so much.
One thing is like um what I think I understand from Pascal's question is like so the main so give me a second, maybe I find some picture. So this one is array, this one is linked list, right?
Okay.
So I think he's asking if I am using linked list right here.
Exactly.
Yeah.
So
Okay.
I don't need to resize, but
Okay.
is that gonna keep the same complexity?
Nope.
I think
No.
we're gonna lose the points why we are using.
Yes.
It won't even be a hash table, right? Yes. So
I don't think so because we don't have a hash.
your hash table works because you have hashes, right? And your hashes, they're supposed to be indices in an array. So if you don't have an array, whatever structure you're building is not a hash table.
Okay, how does it work in Python then when we're using a list? You know that list.
I think it's a hash table made in C to implement it like Like you.
Yeah, so the hash table, the thing about hash tables is that the actual name for the structure is called associative array, right? So it has to, the basis has to be an array, right? Doesn't matter what language you use, the basis is an array.
Array.
How you now, I put your values or your keys, right? Your hash values into that array now depends on the language and whatever you want to use it for. But the basis is an array, right? That is what gives it your constant time lookup. The whole point of a hash map or whatever a hash table is a constant time lookup. That fast lookup is the whole point. So if you're using a linked list, you defeated that purpose.
Do we have linked lists in other languages?
You can implement a linked list in almost most programming languages, right?
The only one I know I'm just asking a question. Anybody can answer. Like,
Okay.
Do we have linked lists in other languages?
Sure. No.
Yes, you can implement them, right?
We can implement it.
I think
You don't have linked lists in
is
C.
a concept, right?
Concept, yeah.
Yeah, it's a concept. So you don't have linked lists in C. You have to implement it, right?
I mean, apart from like Python, do we have linked lists in Python?
Yeah, you use a
of
class.
Of course.
Python,
You can implement in Java. That's not any language. You can implement a linked list.
All right, thank you.
Hi guys.
Hey, please go ahead.
Okay, I got lost. But yeah, I think he was asking about implementing like linked lists because I think for you to access the elements in a linked list, you have to actually traverse through each element. You are manipulating pointers. So I just wanted to say, of course, you can't use it. You can't use it because you don't have direct access to nodes or locations.
Please repeat.
I didn't catch that.
I was saying that, like, for you to ask for a linked list kind of work like curse and stacks. Like, you don't have direct access to locations.
Okay.
You don't have direct access to locations like.
But we can implement it using OOP. OOP.
Yeah, you can implement it. Yeah. So the pointer thing is just the C thing, right?
No, yeah. Even if you implement it using OOP, for you to access at each point that you are inside a linked list, you need to have access to. You need to know where you came from and where you are going to next.
Yeah. Maybe a class containing attributes and the next attribute that we can put a pointer.
It's not like a contiguous. They don't have like contiguous memory allocations. Like memory pointers.
Yeah, they're not contiguous. That's the whole point of.
So we cannot use it. We cannot use it in a hash map because we don't have access to location.
Yeah.
Exactly. So the reason why you can use constant time lookup for arrays is because they are contiguous blocks of memory, and you can index them. You can't do that for a linked list, right?
Yeah, that's very true.
Can we use, instead of a linked list, binary search tree?
It's the same thing, right? The binary search is actually based on a linked list, right? You're still going to have to traverse the nodes. So you are losing the fast lookup, which is the whole point of the structure. You are losing that, so there's no point, right? It's like someone telling you that there's a place where you can eat food, but you don't get any calories from it. You've defeated the point of eating, right?
Okay.
Is the hash table is like the fastest way to implement for like searching, or like there's something that's better than hash table? But
I think hash table
depends. Sometimes if you
is it the same thing as hash table?
Is what?
Dictionaries in Python, is it like is an hash table? Like the dictionary that we have?
Is a hash map, right? Is a hash map.
Yeah.
There's a slight difference, but they are more or less the
So
same.
it means that it means you don't actually need to implement hash tables since you already have a dictionary in Python. Right? I'm just trying to clarify.
Yeah, the implementation is already there.
Exactly. That was what I was trying to say. That why going to implement it on other languages when it's already there?
Yeah. because
It's a TSA thing, right?
the variables and data storing in Python made by C using hash tables.
So we can do
Yes.
it or production.
What? I didn't hear you.
Saying that if you are doing any sort of implementation like that, just for learning purposes, not for production or anything. In Python.
In Python, yeah, of course.
Well, it depends, right? So sometimes you have to implement your own stuff for your own use cases. Obviously, that's like advanced programming, and it's above our pay grade. But some people have to do that, right?
Because, for example, I don't know if the inbuilt table does not have any stuff like collision maybe management. Because of course,
that's where I was going exactly. They've made their hash maps in a way that you cannot have duplicates. So they've removed the need for collision, right? Your keys have to be hashable values. That is strings, integers, stuff like that, right? That has a constant hash. So if you want a system where you can have a collision and you manage your collisions, you can't use the dictionary for that in Python. You then have to implement your own hash table.
Because I think dictionary in Python is it's a hash table made in C. We did face this in our project in ALEX, yeah. That tell us that Python is Python dictionary is a C hash table. Yeah.
Okay, the meeting gonna end soon. What do you think? We're gonna jump to other Google Meet link and we see how we can solve this let's code with hash table. Let's see. What do you think? I will write the let's go there and the meeting here. Okay, so everyone jump to this meet and let's start.
Hash map, hash table. Most times, let me say 49 out of 50, they used to mean the same thing. And the only difference is that technically, at least in Java, right, a hash map can have a null value. That's the only difference, right? So when you say your mappings in Python or Java or TypeScript, they're usually called maps, right? But they're actually hash tables, right? I think it's only Java, at least to my knowledge, that allows you to have null values. That's the only difference that I know between the hash map and the hash table, right?
Is there any question? Do we jump to let's code? Are you guys ready? Okay, let's brainstorm for this one. Who already did this one? Ransom not. So
Can we zoom, please?
yes. So today, as you know, we have PLD about a hash table. If you click here, it's gonna take you to the hash table. So this is one of the essential question that is exist is ransom not. This one we already did it. I think in a string or like array PLD. So ransom not, how we can do that, and we use what we learn about hash table. Let's brainstorm. First, let's understand what they want us to do. So a given toString ransom not and magazine return true if ransom not can be constructed by using the letters from magazine, and false otherwise. Each letter in magazine can only be used once in ransom not. Example, ransom not is A, magazine is B. Can I construct this with this? No, false. Ransom not A, magazine EB. So can I construct EA with EB? I can't because I have only one A. Ransom not EA magazine EAB. Yes, I can use AA. to construct ransom node. True. How we can do this? Let's brainstorm idea. What do you think? By the way, is everyone understand the challenge?
It is as he is asking if ransom node totally included in the magazine.
So okay, maybe we do X calendar. Not included, but because is there like enough character to build it with it?
Yeah, I think that's what you're saying, I think, right? So
Okay, maybe I'm missing.
the idea is if you can create ransom note is a string, right? A magazine is a string. The idea is that if you can build ransom notes by picking characters from magazine, right? I don't know if you guys are familiar with the actual concept of the magazine and ransom notes, right?
No,
So the idea is that in the 70s and in the 80s, a lot of kidnappers used to be caught because they used to type their ransom notes, and the actual, you know, when there are keys on a typewriter, they actually have labels that you can't see, so they used to track them down. So to avoid that, they used to actually cut out the ransom notes of a magazine. So they would actually go to a magazine and cut out the letters and use it to build the ransom notes. That's the idea, right? So now imagine that you're cutting out the letters from ransom notes. Every letter you want to use in your ransom notes, you have to cut it out. Does that make sense? So all the letters in your ransom notes have to be in the magazine. That's the idea.
Okay, let me ask another question. If the ransom note, which is here, it is, for example, AAB, okay?
Yes.
Is a magazine should be or can be ABA?
Yes. As long as you have enough letters to
regardless of the ordering of you don't care with the order of letters, right?
The order is not important. The order is not important. As long as, for example, your ransom note is AAB, as long as there are 2 A's and 1 B in your magazine, the answer is true.
Okay, clear now. Okay.
So this example, for example, we have AAB, right? If I have this box, can I create it? Let's see. I have A. I put it here. A.
Excuse me, Monsef. There is someone who can't understand the problem itself, so we can't proceed to the solution. Can we
oh, no, this is not solution. This is a problem.
Okay,
but so I'm just like trying to explain this example, then we can go in detail. So like the problem is we have this string, right? And I need to, let's say I need to buy enough character from like a magazine. So this is magazine 1, this is magazine 2, right? So if I buy this magazine, can I create this letter? Or if I buy this magazine, can I create this letter? Let's see. I buy this one. Okay, I cut A. I take it right here. I have it here. A. I cut B. I take it right here. I'm missing one letter. So this is false, right? Because I'm missing one letter. But if I buy this magazine right here, and I cut this A, I put it right here. Oh, I need another A. Okay, I have 2 more. Give me this one, cut it, take it here. B, let's see, I have 2B. Nice. B. So this one is valid. This magazine is gonna solve this I can construct this word. So this is gonna be true. What do you think about the problem? Is it like clear? Is it clear? What about Hamid? This is clear, Hamid. Okay. So now how we can do this? And we don't want to do it just in any way. We try to like at least create a hash table just to like or we can create both, like we do it a normal way without caring about any performance on anything, and then we try to do it with maybe hash table. So any idea, brainstorm with me. So
Okay, so for this problem, I
mm,
think I created several solutions. Like the first one that is very bad was to actually go through each letter in the ransom node. Like maybe look through each letter in the ransom node, and then while looping through. I don't know if we should write along.
yeah.
Mm, it-
Okay, so what
is-
language do we
is from-
use?
You can just explain.
Okay.
Yeah.
Okay. So
So
the first idea, which has a very bad time complexity, like O of n square, was like to loop through each letter in the ransom node. So while looping through each letter in the ransom node, I calculate the count. I calculate the count in which that letter occurs in magazine and ransom node, and then I check
okay.
if the count is not the same. So if the count, let's say in the magazine, is greater than or equal to the count in ransom node, of course, I will say that's okay. So, but if the count is different, that is when I actually return false.
Okay, so you are nesting. You are checking a nested loop.
Yeah, that's O of n squared without using
Yeah. So
any
so it's not actually O of n squared, but yes, right. So
m times n squared, something
n
like
times m. Yeah. So yeah. That's what they refer to as the brute force approach, right?
Yeah.
That's assuming you didn't understand DSA, which is the 0 points.
No, that's the default way of thinking.
Yeah, that's what I'm saying now. That's why it's called brute force. That means this person knows how to write code, but the person doesn't know how to do DSA. This is how the person will go about solving the problem. That's what we call brute force.
Can you elaborate on DSA? What that mean?
No, DSA is data structures and algorithms now.
Oh, okay.
First of all, you learn to code first before you learn about data structures and how to apply them. Right?
Yeah.
So if you know how to check for a value, you can solve the problem. It won't be the most efficient, but you can solve it. That's what it's called a brute force approach. That means you're making the computer do a lot of work when you can make it do less work. Exactly. So that's why it's called brute force. So that is where your solution should always start from. The simple approach. You now think of optimizing. Like, is this the most efficient way to go about solving this problem? You ask yourself, what if we use data structure, or what if we use something called premature dismissal, right? That's instead of completing the loop, at some point, once you know that it's going to be false, you can leave the loop, right? And just exit your function. So those are how you optimize, right? Yeah, but your brute force solution is correct, but it's not the most efficient, right?
So my next approach was simply, first of all, calculating that's where now using the hash table came into place, or maybe Python dictionary because I use Python. Yeah. So I had to look through every, so I had to create like 2 different dictionaries, and then one dictionary to actually map the keys to counts. Like I'll go through each magazine and I count the number of times in which. So the key will actually be the letter in the magazine, and the count will be the number of times in which the letter occurs. So I'll do that.
Why are you don't need to count the count of the values in your magazine, right?
Like I have a dictionary, right?
Yeah.
And then I go through, let's say, my magazine, and then I create a dictionary. While I'm looking through my magazine, I create a dictionary, and for each letter that I go through, I note how many times. So I have a key. I have a key. a key. I put the key, which is the letter, and then I put. Of course, I add. So if the first time I'm encountering it, I put it as so it has a key and it has a value of 1. So the next time I'm encountering it, I add 1 to the value. So by the time I'm going through my magazine, I have a dictionary that has keys as the letters and the number of times that letter actually appears in that magazine. I do the same for ransom note.
Okay.
So now I have 2 different dictionary with key value pairs that represent the letters and the number of times that those letters occur. So that's the first stage.
That seems like you're overdoing it, but go on.
Well, that was how I reasoned it out. And that's the first stage. So the next stage now is to go through the ransom node and then go through each letter in the ransom node. And then for each letter in the ransom node, I see if the letter is in the magazine are greater than or equal to if they are greater than, of course. If they are not greater than, then we know that okay, we have a problem here. Not all of them can be used, and that was just the logic. That was my logic. So that was the one that I think I had 70% on lead code, and that was it.
It was hard for me to follow, to be honest. Did you use two hash table? Did you
So
use
the second algorithm, the second algorithm has a term complexity of O of n, although there are a lot of different distances, but it has a time complexity of O of n.
Yeah. So when you loop in series or in parallel, right? When you're not nesting loops, it doesn't matter how many times you loop through data structure, it's still O of n, right? So that's why algorithmic complexity, big O of n, is not exactly, it doesn't map directly to performance, right?
So I think I'm not sure if it's just me, but when someone is explaining how he solve code, like without watching like uh, uh, a whiteboard or like pseudocode, it's hard to follow. So maybe you can like share screen, maybe use this CaliDraw and just simply show how you did solve it or something like that. I think it will be better. Yeah,
Sorry, can I ask a question, sir,
yes,
please?
go ahead.
The solution now, must it be having the O, the O, is it O1 or what they call it, or ON? Like, must it, our solution, must it have the complexity of O1 or ON, or is it anyone goes?
You can't have O of one for a problem like this, right?
Exactly. So that's what I'm asking, because the one, yeah. So anyone can go. ON is fine, right? Even though it's ON.
Yeah, ON is the optimal, right? So unless you have a way to break it up to say O of n or log n or something, but the optimum objective for this is O of n, right?
Okay, maybe we should brainstorm and get a solution. But the guy, I don't know if he can share a solution. And let's see. I think, yeah.
Yeah, we can like whiteboard. Romaric, go ahead, feel free. Also, if someone can explain why it can't be O1.
Because simple. You see, the reason why it can't be O of, well, basically the truth thing about big O is that essentially what you're looking for when you're calculating big O is a loop, right? And every time you have a loop, that means there's at least O of n, and you have to loop through at least one string, right? Yeah, so that's why it's O of n as a minimum.
So
O of one means constant time.
Loop is gonna be
yeah,
because it
at least O of n. So one loop is exactly that's called linear time, right? So the running time will increase as the size of the data structure you're looping through increases. That's why it's called linear time, O of n, right? So anytime you see a loop, the runtime complexity of that algorithm is at least O of n. When you start now nesting, you're not going to O of n square, you're not going to quadratic, or so basically,
Yeah, and then also I think like operations like access, like if you want to access something in a loop, so when it concerns a loop, if you want to access, of course that'll be O of one because you're accessing something directly when you know the index. But if you have to go through finding something, as they were saying.
So that's what I'm saying. If you have the index of whatever you want to pick, you're not actually looking through that structure, right? That's why it's called indexing. You already know where you're going and you're going there, right? You're not looping through the data structure. That's why it's O of one.
Okay,
does that make sense?
Okay, can we just suggest? Let's just whiteboard the solution so that we can. Yeah.
So we have. So this is the ransom node, and this is the magazine, right? We have two magazines. Now in this case we have this magazine. So what is like the entry way? I think someone have angry dog, Provic, Victor. If you can reach your mic. So, um, what is like the most simple way? Is like to just compare character by character, or like
So
I
that's
think
where I
that's
come.
where the initial solution
So
was suggested, which was just a
yeah.
brute force method, which was just to go
No.
through each, like using like a for each
This not
method.
no. That's not brute force, right? So
Yeah, like the
like I said,
initial one that was suggested before
no,
the
you're not
second
even
one.
looping through it. So there's something called premature dismissal, right? There's some things
Uh-huh.
that you see in a program that you know that this thing cannot return true or cannot return false, but not what you want, right? Does that make sense? So, for example, if you look at this, if your ransom note is longer than your magazine, automatically it's false. Do you agree?
yeah, yeah. If
So that is premature dismissal. So if you want, you
Yeah,
can add.
exactly.
Yeah. So, but those are not. You're not solving the problem. You're just checking for an edge case, right? So there's some things that,
That's an edge case.
it will actually save you from actually running your algorithm at all, right? So yeah,
so
that's what it's called premature dismissal, right? So there's some
check
edge cases you have to consider.
size.
So
So magazine should be equal or ransom not.
right. So another thing you want to check is if all the letters in your ransom notes are present in your magazine, right?
Yeah.
As if they're equal. Yeah, exactly.
No. It's not. It's not even equal, right? The magazine can have more letters that you won't use, right? That's okay,
This
right?
one?
No, I'm talking about you want to check if all the characters in your ransom notes
Yeah.
are present in your magazine. Does that make sense?
Yeah.
So I did a problem today called pangram, right? So when companies who make fonts, they often write pangram. The pangram is a sentence that uses all the letters of the alphabet. So you're familiar with the quick brown fox jumped over the lazy dog, right? You're familiar with that sentence, right?
No.
You see it a lot. If you look at any font sites, you see certain sentences that use all the letters of the alphabet just to show you that font in all the letters of the alphabet, so you know what it looks like, right?
Okay, I see.
Yeah, so if you go to Google Fonts.com, you see what I'm talking about. There are sentences called pangrams. Those sentences use all the letters of the alphabet, right? So just as an illustration, you can go to Google Fonts.com.
Okay, Google Fonts. 1 second.
And then one more thing, like, let's say, like, based on the algorithm that you're presenting. Now, if I want to get the length of, let's say, the magazine, or I have to calculate those two lengths, and to calculate those two lengths, I have to actually traverse through all of those elements, because that's how the length function works. I have to go from start to end. So going from from start to end, first of all, I will not need to do this if I have an algorithm that traverses those two elements in the first place. I don't know if you're getting the point.
Yeah, go on.
Yeah, I think the algorithm is cool, but if my process of solving the problem,
so you are making two assumptions, right? You are making an assumption that what language are you using, right? That's the question. So there's some languages, your strings have sizes, their properties, you don't have to calculate them, right?
Okay.
Yeah, so that's an assumption. Yeah, so but go on. That's a good point.
Yeah. So my point here is that if I have to traverse, like I have to go through my strings and then get the length twice. So that's some form of traversal. Oh yeah, maybe there's some bit manipulation that would calculate it automatically, but now I have to do that traversal. So if my algorithm requires using traversal in solving the main problem, and then maybe the comparison, then it's kind of like eating up resources doing the premature.
Yeah. I'm just saying, right? We've not.
Yeah, I'll just also bring up a point in the problem solving sphere.
Yeah, that's a good point. So your point about traversing, you're assuming that you're using, say, Python or C, right? So if you're using a language like TypeScript or JavaScript or even Java, your strings have a property, or Kotlin has size. I think Java, TypeScript, and Java have length. You don't need to check the size of you don't need to traverse the string to get the size. Does that make sense?
Okay.
Of course, no.
Yeah.
That's correct.
Okay.
Yeah. So So in some languages like C and Python, you have to actually traverse the string character by character to get the length, right? So
Okay.
No, I don't
yeah.
think so in Python. There's a lens function in Python you can use.
How do you think the length function gets the length of
That's the point. How does the
you
length
think it's
function work?
magic?
The other one, so how did they get the length? It's not by
No,
traversing.
okay. No, they don't. They have a property in the string that calculates it to a year ahead of time. Right? It's a
Okay.
property. Right? The same way you have okay, if with JavaScript, you have a string, right? You cannot access the .length method. It's already calculated for you ahead of time. You just pick the integer and compare it. But in Python, you have to call the length function, right? Or the magic method in the string, whatever, or list or whatever. And that now involves a traversal of the elements in that structure. Right?
Okay, guys, the conversation is fun, but like let's maybe focus on how we can solve this. Just like we don't extend more time. So what do you think? Now we have two things. Is like magazine should be equal or greater than ransomnet. A character exists in Mac. So then what we gonna do is like first I think we're gonna check this exists here, okay, and then remove it from here, right? We should remove it, I believe, right? Because
so
they say here each letter in magazine can only be used once. As we like see when we were using here, we were cutting the word because if there was only one A and I need two A and they didn't remove it, when I go back to check, I'm gonna find it. So I check this, I remove it from here. I go check this and then I remove it from here. So I'm gonna return true because I check all characters and they all exist there. But
That's true.
I am gonna like each time go to this and like loop through it to check, or there is an easy way to like check.
I did like find an easy way.
Yeah, go ahead.
Okay.
If you want to stream, you can.
Okay.
Do you want to stream or this was just suggestion?
Okay. Entire screen. Okay, this thing. This is my way. Okay. I did declare here an array of size of 256 characters. It's an integer array, but it includes the size of ASCII code characters. So, and I declare here an index start 0. Okay. Then here I go through the magazine string until the end, and initialize my my array at the index of like at the end the first character. Maybe we can say the first character here. Okay. So here what I did is the first element in my array is magazine, is the ASCII value of the first character of magazine. Then I increase it. At the second time I threw it again, but this time I threw it in the I'm going to the ransom notes string, and I try to return the alpha value to 0. If I find that this alpha is not equal 0, I return false. Then Go again, loop until the end of the ransom notes. And if everything is okay, I return 1.
Okay.
I think it's gonna work, but I don't know. Can some okay? I need to implement like
A nice idea.
Yeah.
So what you're actually doing here is you're actually cutting off the characters in each slot, reducing them slot by slot.
Yeah. What? But the problem here is
Yeah.
I think I have okay. Okay. It's like okay. We have here Excel one. Did here this? Okay. What if I do this instead? Yeah. I think it's this is better than. Okay, let's run it. Okay. Okay. But the third one, it says like, so.
So
What is the problem?
I admire people who solve DSA problems in C.
Uh-huh.
Say I admire people who solve DSA problems in C.
Yeah. Okay. Wait a second. Wait. Yeah, it's difficult. It's difficult here to know what is the problem. EEB and EA. Okay.
Sorry, the first one didn't work. The first one you did, I thought it was okay.
The first one that I did, it works.
Okay.
It works. Okay. E++ here. The first one, it works. Yeah. First one, it works. But I think the second one, if I implement the second one, it's gonna be better. Because...
Wait, submit this first so you see if you get an improvement in your time.
Mm-hmm. Okay. Maybe I got it. Okay. So, do you understand what I did here?
I think so. So you loop through the magazine, right? Yeah, someone
Mm-hmm.
was going to say something.
Yeah, I said I don't understand what you did there. You should explain.
Okay. Here I declare an array of size 256.
6.
Yeah. And here I go through the magazine string.
It's basically copying the string, right?
Copying the string. It's not the string, the ASCII code of the string.
Okay.
Yeah, I can't like do char or int.
Yeah, I know, but when you loop through a string, the value at each index is a character. So when you copy the whole array, you're basically copying the string, right?
Yeah, I think so. Yeah, I think so. But okay, if it is like this, I can just like do it like this. But I don't know, bro. No. This way is good, but it's not like the good way. Maybe I gonna face issues when I try multiple examples. So it's like my first week with this code. I don't know how to like to implement implement multiple examples. How can I do it here in this code?
So like you can so
you can create your own test cases.
Where?
Is that what you're asking?
Yeah. I want to like create my cases. Okay.
Yeah. So you can if you scroll down to where you see that part where you have test cases at the bottom of your
to the right.
To the right.
On the right. Yeah.
Okay.
So when you submit, there should be a button where you can add a test case.
Where?
Yeah, at the top.
No, not contribute. It should be at the top.
Click on test case to the left, maybe. Yeah, that's one.
Yeah, test case, yeah. So
Ah.
there's a plus sign, yeah, exactly, yeah. So you have to put your test case. Yeah.
Okay.
Maybe choose something difficult.
Why not just submit it and get their own test cases and use?
I mean, if it's work for the 3 cases, I think it's gonna work for any case.
Not like
So
that. Not like that.
ALX should have taught you better. They have edge cases, right? That will trip you up.
Okay.
So this
Yeah,
is an
yeah.
example.
It's not.
The reason their own worked was because
Yeah.
your code actually is in order. You
Yeah,
get so if
yeah.
A, you get so it's for. But if you try to interchange it, it
But-
won't work anymore.
But what I really want to do is like to make ASCII code of the string, the index where I increase, where I like put the okay, yeah, okay. Wait a second.
Can I ask a question, please?
Okay.
Yeah, go ahead, please.
Not based on what he's doing anyway. It's like in
Okay.
Python. Just a question. Like, is there a way you can use the like a for loop, the for statement in Python to check? Can you hear me?
Yes.
Sorry. Okay. To check if a particular substring exists in a string using the for loop, like for something in something. Does that work? Do you get my question?
So like in array, for example.
Exactly. Is this in this?
Yeah,
I think I've seen something like that before.
There is in. You can use it with string,
like
with
you can find this
object.
in.
Yeah.
Exactly. Let's say we can check if this string it's in this.
Yeah.
Then if it's there, then fine.
That is true.
So I don't know. Just thinking about just the concept. I'm just thinking about it.
No.
Yeah, you can do that, but for the particular solution, it will not go because of what if the letter is the same, where the string is the same.
Yeah. But
if it's the same, it will go. Why? If it's the same, why not? You can find it in
if if the magazine has 3 A's,
okay,
and the ransom was just 1 A, of course. Yeah, let's say the magazine has if the ransom has 3 A's and the ransom has just 1 A, it will always say that A exists, but not the number of A's that you need. So that'll be a problem.
I need to look through to the alpha and check. Yeah. Need to look through the alpha.
Okay.
Okay. Go back.
Guys, go back to a Python solution.
Yeah.
You wanna type it, Omar?
I think Python will be fast. Python will be faster.
Yeah. Let's do Python solution.
I don't know. I'm gonna try this one. I'm trying to.
So this is why you don't do DSA in C until you are very good at it. So C forces you to go low level, right?
Yeah.
I understand what he's trying to do here, but
exactly. We understand what he's trying to do. Is how he's going to do it as a problem.
Exactly. Why it won't work is the concepts. I don't know.
So,
like concept is using.
From this, we learned that in tech interview, just avoid using C.
C. Yeah.
I could have told you that for free, right?
Yeah.
So if you want to solve this in Python, it's probably 10 lines of code of you, all right?
Sorry, who is sharing screen? What's his name?
Me.
Omar.
Yeah.
What you can do is the way you declared this alpha, you also declared you have a second one for the run note or something like that. So the way you are indexing it, so they will both generate the same index. So when you slot it in, you're slotting in for both. You slot in for the alpha, you slot in for the random. You are checking both of them all together.
Yeah. Wait.
So just think about it. It's a nice idea.
Would that solve the problem, though?
I'm just giving him an idea, like what he needs to do. Yeah, he can't do it here. He has to do it maybe later. Something.
Oh, okay. If we have like this, okay. here.
I guess tomorrow we switch to Python because
Okay.
we have only.
Yeah, let's just.
Yeah. Okay.
Okay.
My bad.
Do you wanna type
I
it
took.
or do you
No,
wanna?
no.
Okay,
Okay.
I will share screen.
Stop. I just see it, bro. Just
Okay,
see.
so
Okay.
share now.
But that was a good trial. Well done.
Yeah,
Thomas.
No.
yeah, this was a
Okay.
nice.
So
Yeah.
I was telling somebody,
I forget.
earlier today,
Yeah, I
right?
forget.
So
We was in. We were in. We are in Google Meet, so we can't
yeah,
screen like
Okay,
we can see like.
yeah.
you can
So
see the screen.
Yeah, we can see your screen. Okay.
Okay, we have hash table, right?
Yeah.
So it's gonna be a dictionary. Is this right? Like this?
You can just use curly braces, right? I don't need to use call the constructor. Yeah.
So now we want to use this with the hash table.
You're going to get an additional error. Your line is not indexed properly. Yeah.
Yeah. So like the idea of hash table is like I'm gonna loop through this one. I'm gonna put all the character inside hash table.
Okay, but first question: what are you creating a hash map for?
So for each character. So
No, this is a question. So are you using the magazine string or the ransom note string? So that
yeah.
it's possible to
So
use
this
both.
gonna be 2, and B gonna. Okay, let me. So this gonna be E2, B1, right?
Yeah,
And then
yeah.
I'm gonna check if this
Yes.
in this,
Yes.
and they can like reduce every time I check, I reduce the number.
Reduce the count, yeah. So yeah. Does that make sense? That makes sense, right? So yeah.
Yeah.
That's basically how we go about it as well.
So I know that maybe someone is still confused. So we wanna check AA if it exists in this one, right? And we don't wanna like every time to keep looping through this magazine string. We wanna only loop through this and check here. So if one time I have this hash table that have number of character, then if I go A, I'm gonna just check A, how many number it have. If it have 2, then it's enough, but I need to reduce 1, right? And then I check A again, I found 1, I reduce 1, then it's true. So let's see. What is the next? We said we're gonna loop through each character in magazine and add it to the dictionary. So what we're gonna do? How we gonna do that? We need for character in magazine, right? So each character in magazine, what we wanna do? We wanna add it here. So how we can edit hash table equal.
Hash table.
You're gonna have a problem. It's like
So you
We
have
need to
to
check
you have
first
to
if
you
it
need
is
to
the
check
char
first.
of the table. Yeah, check it
Yeah,
first if it
so
is.
wait, there are 3 ways to go about
Oh.
this. So you can use a default dict, right? A default dict you create when you create the
this one.
dictionary. Yes, all the keys are automatically 0, so you don't have to check if it's in the default dict, right? Is a default dict is a class that inherits from dictionary. It's called default dict, right?
Oh, default dict
So
like this.
yeah, default dict,
Like this?
yeah.
They do
So
underscore or just like this.
no, just like that, just like that.
Okay, didn't colors. I think I didn't see any color change.
Let me just check if it's the same. Yeah, it should be the same, right?
Oh,
Yeah.
maybe the no.
So, but you have to pass int to it, right? So you know that the keys are integers.
Wait, I'm confused. Do I
Maybe
do I need to pass something?
you can just go with the easy method. First of all, you check if that particular
Exists, then increment it. I know that was what you were trying to do before now, right?
Yeah, but you have to check if each key is in the dictionary before it does
Yes,
it, right?
simply if a char in hash table, so you will increment by 1, else set it for 1.
Yeah.
Got me? If a char in hash table,
Yeah, if char in hash table, right?
yes, make this hash of a char plus equal 1, incrementing.
So if char
Yes, in
If
hash
char in
table,
hash table, yeah.
yes,
table
Yeah.
increment
Colon,
hash
then
of a
you say
char.
hash table
it
at
should be in
char,
the
right?
hash table and
No,
it
no, no, no,
should
no, no,
be
no, no. No,
No,
just
no.
add the colon here, right?
no
At
no
the end of this
wait
line.
wait there's a case. So it should be um more than 0, like greater than 0, because if it was 0 then I need to return um false.
You are still
Okay,
building. No, you are still building your hash table. At this point, you can't return false, right?
Just build the hash table first before
You
you
are
can
building the
do
hash table
the.
first before you verify whether it's if you can build your string. So you have to add the colon on line 5. Yeah. So
Okay.
hash table, then
Add the key.
you braces, the square braces char, right?
Okay, hash table
Square braces char equals to.
Plus equal to 1, right?
so we're gonna have a problem here, I think,
Why problem?
because
No, just plus equal to 1, right? You are incrementing the
if
counts if
Yeah.
it already
Or
exists there.
but it doesn't
exactly.
exist at the start
You
here.
know, you are inside
if it
an
doesn't,
if block here, right? So if it doesn't exist, you won't go to line 6.
There will be an
yes,
else
set
for
it as
0
1.
There
as
will
1.
be an
Yes.
else, yeah.
Wait. If it doesn't exist, I will.
After this block, you have
You have an else now, an else to
yeah,
initialize.
you have an else, yeah.
So if char not in this, I could as well started like if char not in this, say char hash table char equals to 1, equals to 0.
Yeah, that's another way to go about it. If you like to reverse
Okay,
control,
so like, so you want to, if it is exist, you're gonna do +1. So like my
Yeah,
idea
yeah.
was like this. So like
yeah, this is
hash-
correct, right? That's correct.
Hash table, hash table car equal hash table.
No,
That's
no, no, no,
it.
no, no, no,
That's
no, no,
it.
no, no, no.
Wait, give me a second.
This is unnecessary.
Let him write his code. You know, codes are different. Everybody
No,
has different ways.
I know what he's doing, right? Yeah, so
Because like this, I felt like we don't need to do that else, because we're gonna, if it doesn't exist, I'm gonna
yeah, I get to
do
pass 0, yeah.
then +1.
Yeah.
If it exists, I'm gonna do +1.
Yeah,
I think this is better, right?
depends. So it's correct, but
Yes,
it's
yes.
not.
No. Why are you setting it to 0?
If it doesn't exist, right? It's
Get or
0.
default. If get or default.
So this is correct, right? But it's not readable. So that's the thing.
All right, it's fine.
Yeah, that's true. Based on readability, it's not readable like so.
Okay,
One will need to
yes.
think
let's
twice
switch
first
the
base.
way.
It's correct.
So
It's
then we're
correct,
gonna
but
do
not
it
readable.
we can do
It's
it in other
true.
way,
No, but that's
So-
smart though.
like this +1, right?
Plus equal to 1, plus equal to 1, right?
And then hash table.
Else, right? Hash table char is equal to 1.
Then
Is equal to 1 now.
which one? Yeah.
Yeah.
So for char in magazine. Okay, now what we doing? Every time we start this code, gonna go to hash table. It's gonna go through magazine, and it's
Yeah.
gonna go through each character and +1 if it already exists, or if it doesn't exist, gonna create it and do 1.
Yes.
Now we have hash table full of character, right?
Yes. So
Now we're gonna go to the other part. Is we're gonna loop through this, and instead of go here and check every time, like we're gonna just go here and access directly. So this is gonna be O1, right? O1, right?
yes, your lookup is O of 1. Yes.
So I go A. Okay, nice. How are we gonna do that? So we can use what we can do is for character in ransom not. Okay, I'm looping through each character. I have this character. how I can check in this hash table if it exists. I can do in if in if in okay, I think
Yeah, if in hash table or keys or something, I don't know. That works.
hash table, right?
You can say if not in, return false as an edge case.
What?
Fish hash table.
No, if try in hash table, yeah, this is correct, right?
Yeah. So I can get it here, but I probably need to go back and adjust this one because
Why?
But how are you going to know how many times the value occurs in ransom note?
You just check, right? So it's a simple check, right? So you just check if the char exists in hash table. Actually, in this case, you want to do premature dismissal, right? Say if char not in hash table, you want to return false immediately, right? Then if char exists, you want to reduce the counts, right?
yeah. So I need to
So you say hash table. You want to reverse line 6, right?
I
So
think
it's minus equal to 1, right? Yeah. Yeah. So
look,
if
there's a problem here.
if
Syntax
no,
problem.
before you go to else, right? Now you want to say if you want to now check the count, if the count of the character in your hash table,
um
There's a problem
if
in number 10.
if hash table char, right?
Something
wait. What is someone have a loud noise? Yes. Go ahead. 5M. You want to say something?
Yes, I was saying you would say if the map, the dictionary not contain the key, the char you are looking at right now, if it doesn't contain it, or the count, the value, I mean,
Zero.
It's less,
is
less than
zero or
0.
less than zero. Yes, is zero or less.
No, it can
You
be
can
0.
return false.
Right?
Else you
Else or
yeah,
if.
decrease it by one. Else you decrease it by one.
Else. Else if. Else if char hash table char is equal 0, then return false. Else if I think that's all.
And
I think it should stand alone.
no, so
This else if should stand alone because
wait. I don't
it will take
understand.
only it will
I
take
don't
only
understand line
one.
12.
That line 12, yes, it's supposed to stand on its own.
I actually
Like
think
if
it's incorrect.
this.
That's what I'm thinking because if you do it that way, what about
Yeah,
if
so
it's going for the next
it's
loop? It
But
will,
like
so
you
my
know,
point
it will
but
become
like
hold
minus
on,
one.
hold on.
but like if
Just
I
hold
did
on, just hold
minus 1 and then I'm gonna
Yes.
check again.
Yes. After you've done -1, you need to check if this value it should be actually be less than 0, not equal to 0. It's actually possible for the value to be 0 and then be correct, right?
That's why I said to check first for the equal zero or less, then check if it's in the hash table. Sorry,
Yeah. So
sorry. At first you would check
that
if
actually
it's
makes
not
sense.
in. At first you would check if it's not in the hash table. Then if it's there, you check if its value is zero or less.
No. Just
And
Then in the else part, you decrease it.
no. It should be your condition is it should be if try and hash table and hash table char the value is greater than 0, not equal to 0.
Do you know why we're having most of these things? Because the whiteboarding was not properly analyzed. That's why we are going back and forth. The whiteboarding has to be very accurate. But it's fine. Go ahead. That's why you see
yeah,
go back and forth, back and forth.
It has to be greater than 0, not greater than or equal to. Greater than 0.
Hash table character. Yeah, so it should be greater than
Greater 0. Right?
Yeah.
Else you return false. Yeah, this should be the complete solution.
Yeah.
So
That is a good
fingers
point. I
crossed.
think the pseudocode or whiteboarding should be fully
Be complete, right?
Yeah. Okay, so this one did work, but submit. Let's see the performance. 61.
It runs. Runtime is fair, but the memory usage is kind of high.
Yeah.
Yeah.
Which one is faster? The other guy, Omar's own or this one? Which one was faster?
No, C well, it didn't actually submit, right? So you can't actually tell. But C code will always be faster than Python code,
Yeah,
right?
because even Python is based on
So-
C, so
Yeah, nice.
And
nice.
then I think like each implementation has its own trade-off. Like if you use the brute force method, you will notice that the memory will be my own memory was very high when I used the brute
Yeah.
force method.
Yeah.
This one
So,
is-
My runtime
but
was very poor.
even if you use the brute force method in C, it's going to be faster than Python.
Yeah. But we are compared. You have compared among Python, among those who did Python. So you're not comparing. with
Yeah,
those
I know. I'm just saying that was someone asking about Omar's solution.
okay, there is like 4 minutes. Let's end it here,
But
guys.
then, how come my solution runtime was faster than this one?
It didn't
When the one looks more efficient.
So another thing about lead code is that the stats are not actually reliable. If you submit again, you see what I'm talking about. Just submit again. You just submit again, you see that there's a discrepancy in runtime.
Yeah,
Okay,
the
sometimes
runtime
actually,
was something.
yeah, so
whereas-
sometimes it can be ridiculous, right? Sometimes. So yeah. But this is fairly consistent. 54, 61, 56 is fairly consistent. Sometimes it's actually as much as 50% difference.
Okay, I want to thank you everyone for joining, and thank you for everything.
Thank you,
It was fun
guys. Thank
session.
you, Mustaf. Yeah, thank you.
Really enjoy this PLD, guys. And tomorrow we do another one. The topic gonna be recursion. Let's see what we're gonna find out. Yeah, recursion. Okay, guys.
Wow, nice.
See you. Have a good night. Good
Thank you,
night.
boss.
Bye.
Okay,
See you
guys.
guys.
Okay,
Bye.
guys.
Yeah.
Good night.